Okay. So now we move to problems 3 and 4. Okay, so problem 3 is just like problem 2, isn't it? It's one angle in a triangle is 3 times the second angle. The third angle is 12 degrees less than twice the second angle. Find the measure of the angles. Well, so we have 3 angles. And we know that since they're in a triangle, they have to sum to 180 degrees. And just about everyone saw that point. That did not escape very many people, that the sum of the angles was 180. So that is a good start. So one angle is 3 times the second angle. Well, let's call that the second angle. So A must be 3B. That's the second equation. The third angle, well, that would be angle C, is 12 degrees less than twice the second angle. Well, twice the second angle would be 2B, but it's 12 degrees less. So now I have 3 equations in 3 unknowns. There is no way that you cannot get the answer at this point. You have enough information. So, to me, the best way to do it is substitution. Let's do substitution. So let's see. I'll start with A plus B plus C is 180, but A we know is 3B, and B is B, and C is 2B minus 12. So let's see, did we do that right? We substituted for A, 3B, because it's the first angle is 3 times the second angle. And for B, we didn't have to substitute anything but itself. And for C, we know that C is 12 degrees less than twice the second angle. Is that right? Is that what it said? So there's my 2B minus 12. Well, now I suddenly went from 3 equations and 3 unknowns to 1 equation and 1 unknown. And it doesn't get better than that. So let's combine all our B's together. So it looks to me like this is 3B plus B plus 2B. Isn't that 6B? Minus 12 is 180. And so 6B is equal to 192 degrees, right? We're all in agreement with that. So B is equal to 192 over 6, which is 32 degrees. Well, if B is 32 and A is 3 times B, then A is equal to 3 times 32, which looks like 96 degrees. Okay? And C is whatever is left over, you might say, from 180, right? So C is either, you can either think of it as 180 minus 32 minus 96, whatever that is, or you can think of it as 2B minus 12. Well, 2 times B is 64, minus 12 is 52. So A is 96, B is 32, and C is 52. So, and you know I can also do this by row echelon form. I mean, if we wanted to, we could put it in standard form, write the augmented matrix, and then go through that process of juggling rows to get the reduced, the row echelon form, and then read off the answers. Okay, so that's problem 3. Any questions there?
Sorry, can we
Ernesto?
ask you a lot of questions?
Yeah.
Do you have my test by chance?
Yes.
I mean, I know.
I think you're in the later class, right? I think you're in that one. Okay. We're going to move on now to question 4. All right. So we're given 2 points on a line. And you're given the point notation like this. Minus 6 and 5 is one of those points, and minus 4 and 7 is another one of those points. And the part A is, what's the slope of the line? Well, you recall that the slope is equal to, y1 minus y0 over x1 minus x0, right? The rise over the run. Okay, well, these symbols refer to what parts of these points? Well, let's call this the 0 point. So this is, of course, x0, and this is y0. And this is x1, and this is y1. Right? So what we're saying is, the difference in the y's, well, y1 minus y0 is 2, and x1 minus x0 is minus 4 minus a minus 6, and that's 2. Do you want to see that in more detail? Some people left their answer as 2 over 2, and I just find that strange. Why would you leave your answer as 2 divided by 2? But anyway, the slope is 1. Okay? Now, if you want to see it graphically, let's do it graphically. I mean, not that I was doing this on the exam whatsoever. I'm just doing this because I want you to see that that's what the slope really is. So here's my origin, and I'm going to plot these 2 points. Minus 6, 1, 2, 3, 4, 5, 6, okay. And then it says to go up 5. 1, 2, 3, 4, 5. So this is the point, minus 6 and 5. Well, what about this other point? Well, he's over minus 4, 1, 2, 3, 4 from the origin, and I go up 7. 1, 2, 3, 4, 5, 6, oops. Right there. And I think you can see, if you draw the line through what we've just done, that's exactly a slope of 1. So all you're doing is you're taking this rise and dividing by that run. So of course this is y1 minus y0, and this is x1 minus x0. So the differences in the x's and the differences.
Can you do that again? How did you, from the points, how did you do the graph from the points?
Okay, I'm going to redo that because I kind of ran off the graph, didn't I? So the way to fix that is...
You started 0?
Yeah, here's my origin. So we want it, that first point says to go minus 6. 1, 2, 3, 4, 5, 6. Okay, there's minus 6 right there.
Minus 4.
And it says to go up, to get to the point, I got to go up 5. 1, 2, 3, 4, 5.
Oh, okay.
Okay, so this is the point, minus 6 and 5.
Okay.
Okay, now where's this other point? This other point is at minus 4 and 7.
So it's
1, 2, 3, 4, and go up 7. 1, 2, 3, 4, 5, 6, 7.
Oh, I see.
Minus 4 and 7. And I think you can see that that is exactly a slope. It's certainly a positive slope. We know that, so that's good, it's possible. And if you look, sure enough, if you connect the dots, you are going through, for every unit up, it's 1 unit over. See? There's a rise and a run, is exactly 1. So that has a slope of 1. But I don't think for an exam, you wouldn't do it graphically. There's no point in doing it graphically when you can do it just algebraically. And just use...
No, but you have the graph of the equation.
Oh, that comes later, right?
That comes later, but that wouldn't be the same thing then.
Right.
It'd be different, right?
Well, I'm just saying, you should calculate the slope using just plain algebra and
Right.
the arithmetic result. So that's the slope of the line. The slope is 1. So now it says, write the equation of the line in point-slope form. Well, the point-slope form is y minus y0 equals m times x minus x0. And these could have been y1 and x1, by the way. It doesn't matter which point you use. So what is this?
You can't do it y equals mx plus b?
No, that's not point-slope form. That's slope-intercept form.
That's how I figured mine out.
Yeah. Okay, so but this is point-slope form. Why do I call it that? Because there's the slope, and we're referencing one point on that line. Doesn't matter, any point on that line will work. And I'll show that in a minute. So let's just plug it in. Y minus y0, well, that's y minus 5. The slope is 1, so x minus x0 is minus a minus 6. So y minus 5 equals x plus 6 would be the point-slope form. And if you want to put it in y equals mx plus b, just put the minus 5 on the other side, and you get x plus 11. Y equals x plus 11. Now, suppose I had chosen, instead of y0, x0 and y0, instead of choosing this point, I had chose the other point. Would I get a different answer? Well, let's find out. This would be y minus y1 equals m times x minus x1. So I've used the other point. Well, let's plug it in. Y minus x1 is y minus a minus 4. The slope is 1, so you can forget that. X minus x1 is minus a minus 4. Oh, what did I just do? I'm sorry. Mistake. Y minus y1 is 7. Okay, and x minus x1 is minus a minus 4. So we have y minus 7 equals x plus 4. And again, we can put the 7 on the other side to get the slope-intercept form, is equal to x plus 11. It's exactly the same equation. You can use either point.
When I learned you have xo, x1, y1, and when I learned it last semester, it was always, and I don't guess it doesn't matter,
Right.
x1, y1, x2, y2. It's one
There-
doesn't the other, right? It doesn't really
Right.
matter, it's just a placeholder.
Yes, this is an index. It's
Yeah.
just a subscript, it's an index.
So-
I could have said Alice and Bob.
Yeah.
I could have said X Alice, Y Alex, Alice, X Bob, Y Bob. That's, so, you know, you can put any index you want on there. Okay, so that's that part. Now what is it? Oh, graph the equation. Well, we actually just did that, didn't we? So there. Well, we graphed it. We graphed the lines.
But that's not, is that?
Let's do it. Okay, let's graph the equation in y equals mx
Yeah,
plus b
it would be
form.
11.
And it's going to be really hard for me because 11 is up here. See? So, you'll get this exactly the same line. Let's go 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you can see that this
Go.
line goes right through that point.
But you have to come down 1 and over 1.
Right.
Yeah, so that still would be on that line.
Yeah, exactly. Okay, so that would be problem 4.
4C.
Yeah, we just did part C.
It's not 5.
Okay? So we're done with that. I'm going to stop the recording.